Hello and welcome to the second Vehicle Lightweighting Conference brought to you by Autocar Professional. Now, as we know, making vehicle lighters has been a long-standing goal of the auto industry because of the obvious advantages of weight reduction, which brings in terms of fuel efficiency, less wear and tear, and increased life and lower emission. And it's this last point, which is lower emissions, that has made the need for lightweighting especially critical in the present scenario, where industries have strict goals of decarbonization and net zero targets. We have a power-packed session over the next 2 days with industry experts sharing their thoughts on the new technologies and innovations in this field of lightweighting. And to kick off the inaugural session, it is our pleasure to invite the Country Managing Director and CEO of Renault India, Venkatraman Mammalapalli, to give us the keynote address. Over to you, Mr. Mammalapalli.
Thank you, Hurmas. Good morning, good afternoon, and good evening, all. Today's world is more concerned and should be, for all reasons, on environment and the social responsibility. Companies moving towards decarbonization and net zero targets, as Hurmas just said, it's become important and it has become the main goal for every organization who is running the business, and as well as to keep up the society which they are living in together. All across industry, we are trying to optimize our natural resources and as well as well-being of humanity. And it is very important that humanity's health is our business to continue, grow, and survive, as well as keep everything in order as we progress as a humanity on this planet. Based on this, there is something called ESG framework, which is a key to every corporate which is working and conducting their business. ESG is basically environment, social, and governance. Environment, obviously, we have to take care of environment where we are working, where we are living, and to keep ourselves in a good condition for us as well as our future generation as we move it. Social, we have to take care of shareholders, stakeholders, community, and the supply chain globally, which we are using and in a proper order. Governance is the management who is responsible for the business. As management, we are responsible to take care of environment and the social governance which is necessary. Put these into KPIs and tracking as well. The most important thing is social responsibility, which is also governed by CSR in various corporations. And health and safety is critical in the given context with a lot of things which we saw in the past couple of years, whether it is COVID or any other issue related to health and safety. And this is the framework which ESG is formulated. Meanwhile, as it goes, in 2015, UN made 17 goals, and actually 193 countries got engaged to reach the goals by 2030, which is Sustainable Development Goals, which is also called SDG. And this has become very critical for every corporate. It is being tracked. There are nations who are committed to it. As I said, 193 countries are committed to this SDG. And every organization, every country is working towards this. With this background, let us dwell into lightweighting concept and more focus on automotive, as vehicular emission is agreed to be one of the major factor of pollution. First, let's all understand and shift our paradigm on lightweighting. It's very important, and I want to be very specific. I'll go a little more detail in future as we speak. Lightweight means efficiency, strong, reliable, and a better performance, not otherwise. In the olden days, we had been thinking that lightweighting means weak and it is not safe, but it's not the case in the new generation as we move ahead, as the automotive evolution is taking place. Today, lightweighting as a whole concept towards future efficient mobility solutions, doing more with less, light is right. There are a lot of acronyms which people are using. I would like to share some of the slides which will detail more on lightweighting. So can I have the presentation, please? Yeah, can we go to the next slide? See, this shows the benefits of lightweighting, and what is important here, it starts at the design stage. It's not that it's done, the car is done, and then we proceed with lightweighting. It's done right at the design stage. And how we optimize, what are the levers, that's one which I'm going to touch about. But before that, let me change the paradigm by stating that lightweighting means fuel economy, less CO2, which is again related to emissions, price advantage, there is price advantage to it, cost of ownership, when we have some maintenance or something happens, it's easy and less cost for us to maintain it or repair it. Performance is much better. When I say performance, lightweight takes lesser braking efficiencies. I mean, you don't need to put a lot of load on your engines. The smaller engine can give you better efficiency and more space and storage. When you have less weight, you can put more load into the car space. So that's the whole benefits which we get on lightweighting. And the way we have to optimize at the design stage, obviously, is the dimensions, material, the second most important thing. Powertrain optimization, as I just said, you don't need big engines because higher mass to move, you need bigger engines, lighter the weight, you can move with the smaller engines, which are more efficient, whether it's on fuel economy or on emissions or else in maintenance, as well as on the cost. And packaging optimization, when you have lightweight for the global supply chain, it will be much easier. You don't overload on your trucks. You do optimization, means you have a parallel governance on the emissions. And then process optimization, as you use different materials, you have a lot of process optimization which we can do. Instead of putting heavy hammers and presses, you can go for a smaller machines, more efficient process, high-speed production. All this can be done. Product definition also can be optimized, whether it is seats, which we will talk about it in a couple of slides from now. But a lot of process optimization also takes place, which means we spend less energy in processing those material and the way we take out the product for the final assembly as well as the vehicle. Can we go to the next slide? I'm just talking about the Kwid as an example, being Renault. Kwid is our product, so I want to just put some perspective to this. Less weight for its size. In the whole market at the point of time when we launched Kwid, if you see the overall length of the car versus the weight, Kwid was the best. And this proves that less weight doesn't compromise on size. It definitely gets you size even with the lesser weight. How do we achieve this lesser weight is the one we will furthermore elaborate. Fuel efficiency, it's very critical again. In India, we know our fuel prices, the way they are fluctuating and always on the higher side. And lesser weight means smaller engines, better efficiency of the engines and more fuel economy. So again, if you see the competition, which we have narrated as C2, C3, C1, I didn't want to put the names. So with respect to them, the Kwid being lightweight, having a very high fuel efficiency is the second box, which is shown on the right. And more exterior volume with less weight. Again, if you see the space, which we spoke about a few minutes back, that less weight can give you more space because you don't occupy large spaces and you can economize on the volume which is available in the car. So that is the second point which we are trying to establish. And power to weight ratio, if you see the last box on the right bottom, which shows the description of the weight versus the power. The lesser the length of the vehicle or more length of the vehicle and the power you optimize is the best way to go about. So these are the four important criteria, which is a snapshot. I'm not going to elaborate more, but just showing a snapshot that how we have the advantage on lightweighting, and not only lightweighting, but also using the space as an economy, because the real estate is fixed and we got to use very, very economically and still move at a much faster pace, giving satisfaction to the customers in all aspects, whether it is fuel efficiency, whether it is the safety factor and other related satisfactions of the customer. So all this can be achieved with less weight and giving them more. Can we go to the next slide? These are a few examples which is a global trend. It is not specific to Kwid, though it is being adapted in Renault globally. And there's one good example that we had one model in the olden days which we used to make. which had the body upper structure of 134 kilos, and we got it down to 89 kilos. And we used various types of steel. In those days, we started off with tailor welded blanks, where you're using different thickness of metals and trying to weld them and then blank them and then shape them up, and then go for advanced high tensile steels, ultra high tensile, which is again available easily nowadays in the marketplace. And we have used aluminum sheets and magnesium material. For example, if you see, twin steering wheel has magnesium inside, so it reduces the weight, it increases the efficiency, and as well as the cast aluminum, which is again a trend. Most of us are using it, and then followed by plastics. There are various types of plastics, and whether it's fiber reinforced plastics or sheet molded compounds or thermosetting plastics are also being used. So if you see the change of 134 kilos to 89 kilos on the upper structure, it's a significant improvement, which actually adds up to the vehicle performance, as well as loading the engine reduces drastically. Can we go to the next slide? This is the opening panels, which is on the side body outer as well as the doors. Similarly, it's a same example coming out of one of the car. From 111 kilos, we went to 61 kilos. It's almost 50%. And this is not that easy, because it has to take the side crashes, it has to have the safety, as well as we have to reduce weight. And these are the ones exercises. Again, we are talking about steel, aluminum, plastics, which is getting added to it. And in some cases, we also used perforated steel for making the side inners or body inners or door inners, so that we can reduce the weight and still keep the strength of the metal as is. So these are the few examples. As we move ahead, I'll also talk about the interiors. I'm not sure if you would have read in many of the newspaper articles. Can we go to the next slide, please? Yeah, where people are using natural products, natural material, whether it's coir or banana leaves and so on and so forth. And here are some examples where we are also trying to do on insulations. Especially on insulation, we are using cardboard, not the normal cardboard which we are talking about, or high absorbent polyurethane, as well as light non-woven carpets for the underfloor, and which also helps us in NVH significantly. And parcel shelf, which goes behind the seat, it is also used through natural fabrics or natural material, and this is giving us a significant. Definitely, we will have weight reduction. But yes, there is little bit of cost associated to this, but overall, we are trying to balance between the weight and the cost. Lightweight doesn't mean that it is expensive. Again, this is one more paradigm which we all have to understand and shift from them, that lightweight also gets us cost benefits. In the initial stages, when we were nascent in the automotive industry, this was the thing. Yeah, lightweight was expensive because people were switching to aluminum. But now, as we progress, there are a lot of new material which are coming up, which are very natural and as well as not very expensive. It doesn't mean that they are cheap, but however, they are cost competitive, in my opinion. And similarly, in instrument panels, we are using microfoam injection. And if you see, most of the instrument panels which you will see in future coming up will all get into microfoaming injection molding consoles, and which is a key. It's not only aesthetically, it is giving a good looks, but also reduces weight significantly and adds a lot of strength. And natural fiber, glass fiber reinforced thermoplast, which is again a game changer, and it has been in use for now a decade, and this is more evolving. And as we see that in India also, we have started using it, and we'll continue to see how best we can adapt these materials as we move ahead. And very importantly, on the seating, glass fiber reinforced thermoplastic is call of the game. Not many are using it as yet. The high-end cars are currently using it, but this is the future for lightweighting on seats. Seats is one of the heaviest component, which we all should be concerned and work on that to make sure that we reduce the weight substantially. Then comes exterior. I'm not going to talk too much about exteriors. There are a lot of such actions which we are all taking together. Can you go to the next slide? So integral microfoaming injection molding to a conventional injection molding. These are the things which we are trying to evaluate and see how well we can balance the weight to the cost ratio. And this is a trend which is being followed across automotive industry, and we will continue to do so. And what is very important and critical is, it's not only now we are talking about being green, we are talking about pollution, emissions, and so on and so forth, but it is also safety. So these new lightweighting material, which we just spoke, is also giving enough strength and increasing the safety of many of our cars. And you can see that there are 3-star rating, GNCAP, 5-star rating. These all can be achieved even with these lightweight materials as we progress further. And as Renault, globally, we are working on this direction along with our alliance partner. And we are moving in this direction. Even the new car generation, which we are bringing in India, we will be using these lightweight materials. And more especially, this is critical at this point of time as we are all going towards EV. And the battery is the most expensive commodity, and we want long range of mileage distance to be traveled on the battery. And the best solution for that is the lightweight material, which we should be using on the vehicles, which enables the battery loading will be reduced and we will have a long miles to go. And this the second thing and foremost thing. And moving ahead beyond this is even reducing the weight of the batteries is also call of the day. There are a lot of material which is under research. I'm sure that the next generation of cars, you will see this coming up, and I'm very sure that we all will be together working on this lightweight materials very seriously moving forward. And it would be very critical for all of us to make sure that we keep our environment as safe, green, and leave the planet as is to our future. So with that, I let Hormas take over.
Thank you very much, Mr. Mamalapale. It's really very interesting. And, a couple of points which I wanted to bring up, or one key point. You raised the issue of lightweight materials not being so expensive. I mean, in the Indian context, how cost sensitive the Indian market is, especially at the lower end. Quid is one example of where you've really had to fight, work under a lot of cost constraints. Do you think it's still a challenge? Because while you said it's not that expensive, it's still not cheap. That was one question, is that, lightweighting, does it still come at a cost, which in the Indian context can be a challenge? And the second question is, to make it on scale, certain materials are very difficult to make at a certain level of scale, which again limits their kind of true potential.
Okay. Hormas, it's all matter of evolution and time and volumes. Okay. And if you see the lightweight material, which we had been talking about, is once upon a time, we were in a paradigm of using, instead of steel, aluminum. Okay. And aluminum was definitely expensive then. But using aluminum appropriately where it needs to be used and then balance the whole equation makes a lot of sense. If you see one of the car which we have made, I can't give the example now because it's still not launched. We are using perforated aluminum sheets. Okay, so you are reducing the weight. Aluminum is fully recyclable. So
and you still have the stiffness as well. You've not compromised.
Exactly, you're not compromising on the stiffness, because it's all in the matter of design, how you adapt and how you bring about the strength and still reduce the weight and optimize the cost. So instead of using high tensile steel, you can always use different material and try. I'm not saying it will be as cheap or as cost as the steel is, but there are adaptations which you can do it to minimize the impact of the cost and still get you a better strength, better reliability. Longevity is more critical, and the efficiency for the owner who is buying the car. The cost of ownership reduces drastically.
So what you're saying is, over the life cycle, the initial cost might be compensated by the lower running cost, which the lightweight material brings.
Exactly. So it is acquisition cost versus the running cost. So that's the balance which we all have to strike upon. And for a customer who can understand this, will definitely appreciate this. It's not that 1 kilogram of steel is equal to 1 kilogram of aluminum. So you've got to see that 1 kilogram of steel is definitely equal to 350 grams of aluminum. So we have to see how we can make the same part at this aluminum by weight and cost. and not necessarily they are equal, but you got to balance this.
Right. And, the other question was on scale. Some of these materials may be a challenge on scale. I mean, look, everyone is so familiar with steel. You have these massive press shops just churning out, panels at a very fast rate. Aluminum, a deep draw can be a bit of an issue. So do you think, even producing some of these lightweight components at scale is also a challenge?
It might be a challenge today, Hormas, given the situation, but definitely as we evolve, there will be some process which we all will come out with and make sure that we meet our demands. Right. And as I keep saying that demand is the mother of invention. So I'm talking about banana leaves, coils, those type of things. Making parts out of it is also not a high production item, right? So there are some processes which we will evolve. There are some researches being done. There are some implementations already being taking place. Probably you will see in the generation of EV cars which are going to come in near future. All the EV cars have to work on the lightweighting necessarily. Otherwise, we will not be able to sustain the battery costs, weight, and the mileage which we need for.
Right. Mr. Mamalapalli, a lot of questions coming in. Before I let you go, I just want you to answer maybe one or two very quickly. Sure. We've got Mr. Shripad Tokekar, who's asking, how do you see the role of CAE or computer-aided engineering in lightweighting? Definitely,
as I said, it starts with design. Okay, the whole thing is not that we make a car and then try to lightweight it. It has to start with the design, and not only CAE or CAD, but it has to come with artificial intelligence to see how well the strengths of the metal material lightweighting can help us, and which is already in practice. By the way, it's nothing new. It's already in practice. People are using it in Europe for sure. It is us in India that we have to evolve and adapt these, and we are not late. Actually, we are on track, and we should be able to do this as quickly as possible. And definitely artificial intelligence will play along with CAD and other softwares. Right. And just one last question from Sanjay Kumar. His concern is side door panels. The lightweight, will it lead to poor performance and side impact scenario? The door panels are of less stiffness, but I think you in a way answered that. But if you just want to quickly touch upon that light doesn't necessarily mean weak. Yeah, I probably missed my statement on that. Side crash is very critical for side outer panels, and we have worked on this, and I'm sure that we have achieved the necessary results. And if you know, we already got the G and CAB rating better, and we are improving further on the driver. And this is because not that we have used lightweight material, we have used the lightweight material appropriately, whether it is tailor welded blanks or by strengthening, ribbing them, or using other sandwich material. We can definitely strengthen and get the required desired results on the crash. Right. Well, we've got lots more questions, but I think we've run out of time. And really, I think, Mr. Mamalapalli, we had a lot of interest from the audience. Questions have just been pouring in. Clearly, it's been a fascinating presentation, a great kickoff to this section. Clearly, a lot of advantages in lightweighting, a lot of opportunities. And I think that is the way to go. I think, making vehicles lighter, there's only benefits to that. And a lot of innovation and technologies which you have really highlighted, and I think this is the way forward for the industry. With that, I would like to thank you very much for kicking off our session, and really appreciate you sharing your thoughts and views with us. Thank you very much, Mr. Thank you, Hormas, for having me, and I apologize to all the participants that I could not continue as I have a scheduled appointment further. So thank you very much, and wish you the best on this 2 days session on the lightweighting. I'm sure that there will be good results. Please do share with me so that we can adapt a few of them in Renault too. Thank you.
Thank you so much. Thank you. And over to you, Mayank. Thanks. You can take the next session.
Thank you so much, Mr. Mamalapalli and Hormas, for that great start to the 2-day event Vehicle Lightweighting Conference of Autocar Professional. And I would now like to take the proceedings further and invite our panelists for the first panel discussion. We have Dr. Tapan Sahu, who's the Executive Director of Engineering, Maruti Suzuki India, and Mr. Sitaraman Pritikumar, the Vice Director of Transportation, Performance Materials, BASF India. Gentlemen, thank you very much for taking out the time and joining us for this session.
Good afternoon. Thank you. Thank you, Mayank.
I think the keynote had some very good takeaways, in terms of getting a brief overview about what exactly is driving lightweighting today in the automotive industry. And I would like to, begin with that only, and want to get each of your broad perspective about what is essentially driving the need for lightweighting today. Dr. Sahu, starting with you first, as an OEM. So want to understand from you, is it really the end consumer? Are you looking more from an end consumer's point of view, giving the consumer a more efficient, more reliable vehicle, which is also easier to maintain? It is also cheap on the pocket. Is that what is driving lightweighting for OEMs right now?
Thank you, Mayank, for the question. Thank you, Autocar Professional, for inviting me. I think before answering your question, I think I'd just like to share a perspective that lightweighting as a connotation probably has some different meanings for different people. So if you look at history and look at aviation industry, lightweighting has been the primary focus because you can carry more load as you go along. The payload will be more, it will be more fuel efficient, and that's where all the innovations started for lightweighting. So in terms of passenger vehicles, what I'd like to say is that there are primarily three drivers which are driving the lightweighting, or I would say the right weighting in the auto industry. First driver is that the drive towards carbon neutrality. As we know, all over the world, different countries have committed to different timelines. USA, Finland committing to 2035, Europe 2050, Japan, USA 2050, China 2060, and India 2070. And the carbon emission is one of the major drivers for improving the fuel efficiency of the vehicle or reducing the carbon emission from the vehicles. That's number one. Number two, there is an increasing expectation of customers which is changing across the globe and across the segments. What we see particularly in India, for example, we have a wide segment of customers, starting from entry-level cars to mid-level cars to premium cars. But as people are becoming more and more aware, and they are getting global exposure, and lots of new offerings are coming into the market, we also see liking towards more technology, more features in the vehicles. So these features also, in a way, add to the weight of the vehicle. So therefore, the optimization or the right weighting comes into picture, that if you have to give a priority for a particular customer liking, then how do you balance it out in the vehicle structure? And number three is globalization. Globalization not only in terms of global engineering, but globalization in terms of exports. When you are looking at multiple markets, you have to look at various regulations in different countries. And if you are developing a platform which is going for global market, then how do you really do the right sizing or the optimizing of the different platform development so that the vehicle weight is actually really calibrated? Vehicle weight has a significant impact, as you saw in the previous presentation as well, in terms of fuel efficiency, in terms of performance, in terms of safety, in terms of ride handling, and so many other things. So therefore, these are the three key drivers which are actually driving lightweighting or right weighting in the automotive industry.
Right, very well said, Dr. Sahu, and I will take that to Priti. Priti, as a supplier, as a tier one major in the country, so what is your driver for lightweighting or right weighting? If I may call it, like Dr. Sahu mentioned. So is it the need which is coming from the OEMs, which are sort of moving towards more and more lighter and the right weight cars, or is it also the sustainability, which you also believe is sort of the most critical factor right now?
Thank you, Mayank, and thank you, Mr. Tapan, Dr. Tapan. I think as a raw material supplier or as an innovation solution provider, when you say as a raw material supplier, three major things. The demand is the major king, actually, and the situation. So when you see the whole automotive development in past few decades, you can see the globalization is one which is driving the total part of the industry. And as Mr. Tapan said, it's also the right weighting and also how it is getting integrated with the different compliance of the different countries. And today, automotive industry is not a localized industry. It's totally global. And what happens in States, what happens in Japan or China or Germany is same in India. Maybe the timeline would be little different, But the best example is like how we jumped down from BS4 to BS6. We have skipped BS5 and we went to BS6. And it's because of the global drive towards carbon footprints or carbon emission. So as a raw material supply, it is mainly driven from demand. Unless until there is no demand, having a solution in our hand without a demand makes no meaning. And second most important driver is with the demand mainly on the emission part, efficiency part, because India, as you rightly said, at the bottom of the pyramid, the drive is mainly from cost efficiency, cost of ownership, and also the price tag of the vehicle, right? So it all drives also for the lightweighting. And the third most part is, if you see the development of safety demand in India, compared to 10 years back and now, it's hugely driven. And this also comes with the lightweighting. And as rightly Mr. Tapan said, lightweighting with the right weighting, and some questions also connected to whether it is cheaper, whether it is stronger. And exactly it comes from the cradle, right? From the design point of view, when you see this, and the proper product, the right product has to be designed with all these demands like efficiency, cost, integration. Another most important part of lightweighting, when you see a metal part cannot be integrated so well, whereas a plastic part or a lightweighting part, anything, can be integrated much efficiently. And that also puts the cost of the total system much efficient than a singular product. So in a nutshell, for a raw material supplier or a solution provider, it is basically the demand, the safety part, the emission, and also the drives of the other cost issues like the price tags and ownership cost. So that's what I would like to say from the perspective of the raw material supplier.
Right. So we will come to the cost angle, Mr. Priti. So, which areas in a vehicle, and I'll just take the example since we have Dr. Sahu from the passenger vehicle segment, which areas within a vehicle, we also saw in the keynote presentation, is it now more of the powertrain? Because, we're also seeing a very big transition happening away from these conventional powertrains. So is the powertrain still one of the major areas where companies and suppliers are working to reduce the vehicle weight, or has the focus shifted away to the exterior parts, the side opening parts, or the interior of a vehicle?
I think the focus area traditionally has been the body in white and powertrain. However, over the last decade or so, focus is there in every area. I think I'll say every gram counts actually in that sense. So when I said right weighting, if, for example, just as an example, if you take a X amount of vehicle weight today, and you are increasing the BIW weight because of some reasons by delta X, what happens is that you have to adequately, also redesign your suspension system, your other associated system, and do the testing, etc., validation in terms of safety, in terms of performance, in terms of fuel efficiency, everything. So what happens is weight increase is not only on one area. One area weight increase actually impacts other areas as well. So we may think that, okay, body in white is the only area which is increasing, but body in white increase actually increases the weight in suspension, braking system, because consider just simple physics. For the same mass to be stopped at same, at a particular distance, you need to, if you're applying the same force, a heavier vehicle will stop at a longer distance. Therefore, you need to strengthen your brake system. Similarly, if the weight is increasing, you need to retune your suspension system, have the right kind of ride and handling, to have the right kind of handling. Therefore, I said that it's not lightweighting, which is actually the thing, it's right weighting. So when the weight reduction is targeted today, it is being targeted in all areas. So starting from BIW, for example, starting with how can we replace steel by high tensile steel or ultra high tensile steel, whether it is powertrain, the traditional sheet metal air cleaners to plastic air cleaners, or ferrous material to aluminum. Those are the changes which are happening in case of powertrain. Then exterior, interior parts as well, all other equipments. In fact, simple examples like a steering lock, which was used to be some kind of a different kind of material, is being made in magnesium today to reduce weight. So every gram will count because every gram that you are able to reduce and optimize it and lightweight it will help in all the other advantages. So whether it is cost, efficiency, safety, structural integrity, reliability, and so on. So today, Mayank, I think if I just answer your question very in a clear term, every part of the vehicle will matter when we are talking of lightweighting.
Right. Mr. Kriti, you would second that opinion, what Dr. Sahu has just mentioned?
Sure, I will surely second the opinion of what Dr. Tapan has mentioned. Just to add in a little bit extra points, as he rightly said, the conventional powertrain and the other parts are the earlier targets, because those are the things which were really steel or real iron, making towards aluminium, and then it goes to plastics. As the time moves on, the internal combustion engine is getting downsized. And this is also a biggest development from the engineering part of the car. A 2-liter engine or a 2.5-liter engine guzzles out 6 kilometers per liter, and it's used to give 106 bhp power. Today, you can see a 1.5-liter turbocharged engine gives 185 bhp in a much smaller size, and it can actually handle other features in the same space or in a much better way. And this all has come from the engineering marvels of downsizing and lightweighting. And this is one example from the internal combustion engine. It is still going on. Maybe the macroeconomic is going towards e-mobility because of other targets. Maybe the speed of developments in internal combustion will be diverted towards the other lightweighting, which is like electric mobility. But as he rightly mentioned, the most important part of the car, which is not going to change much in future also, is body in white, which is going to be there for e-vehicle, or it is going to be there for even for a hybrid or for the internal combustion. That one is a very big target, and that's what also has been mentioned by Mr. Venkatraman actually in his presentation. So those parts also highly targeted, and the interiors, which is also maybe optimized with the futuristic mobility, maybe shareability and other things going to change, but still the seats are going to be the steering wheels, maybe changing to an autonomous driving structures or something. So those weight targets are also very much well targeted. So seating, again, 25-30 kg of a seat, obviously if it is going to be reduced by 10-15%, who don't like it? Basically, people will surely target those things, and it is a target. So then again, with the change in engine to a motor, the engine noise creation areas are going to be diverted from road noise creation areas. So the insulation part of those road bearing sound creation centers will be targeted. For example, absorption from the engine firewall will change to a carpet, because the road bearing sound will be the most important thing for the future. So as he rightly said, wherever there is a possibility of weight reduction will be targeted, but with the trend, the priorities may be different. So from internal combustion engine, the priorities may differ with the different OEMs. But end of the day, weight reduction isn't synonym for any mobility industry now. So that's what I would stop there for my comment, and I surely second what Dr. Tapan has mentioned.
Right. And Dr. Sahu, you mentioned that, every ounce, every gram counts. So in that sense, from an engineering perspective, so are we seeing a very concurrent engineering happening right now in the automotive space when you talk about conceptualizing or developing any new model? So are you seeing the entire, teams from different domains sort of coming together collectively to sort of, vision from a long-term perspective, visioning the end of the project, and then starting off in a very concurrent manner to achieve the right weight and the right vehicle size?
Yeah, Mike, I think you are absolutely right there. I think when we start a program in particular, we would have some kind of, shape, size, dimension, in mind, and we'll be targeting certain parameters. So key parameters from customer point of view, what kind of a vehicle it should be, what kind of a design, and because that design is going to, impact the aerodynamic drag and therefore the fuel efficiency. So if design impacts, then which vehicle side we can actually optimize to get to a level of efficiency which is liked by the customer. So therefore, I keep saying it's all about optimization and right sizing. So once that happens, then the overall vehicle weight is targeted. You have a certain target. You have a platform A, you are going to platform B, or in platform A, you are developing a top hat. So you start, distributing kind of targets to different domains, like you said, that okay, this is the kind of target you should do. Whether it is reduction, some area it will be plus. For example, we talked about e-mobility. If you're talking about e-mobility in a current platform or e-mobility in a different platform, the battery weight itself is so high. I mean, if you talk of just battery, it adds to 300, 400, 500 kgs to the overall vehicle weight. And it's really so-called dead weight. So how do you really optimize battery size, or you compensate on other things so that you're able to get a better efficiency? You can't, of course, compensate 500 kgs. But if I talk of a conventional vehicle development also, there also, because of certain feature addition, something else, you would have weight addition in the vehicle. So therefore, you start distributing, okay, exterior, let's target new things. For example, let's say, how can you use more ultra high tensile steel or high tensile steel, or how whichever parts we can use plastics, for example, or composite plastics. So that's one area of examination. The second area of examination could be that in powertrain, what can we do? In seating system, like Mr. Sitaraman was giving the example, it's also another good example. Seating system with the right kind of material, you can have leaner seats, which will be equally comfortable, low in weight, but good in performance. So that's the really beauty of engineering. I say it's a real engineering challenge or real engineering problem which engineers would love to solve, because engineering is all about optimization. It's about problem solving. So
and now more so with ventilated seats becoming a very common feature even in cars of the mass market segment. So it is imperative that you have to reduce the overall weight of the seat structure.
Absolutely. When you are adding the motor weight, so where do you compensate?
Right.
So you have two motors in every seat. So therefore, you start looking at every area, and each area works in tandem. And it's not only that. Once the targets are decided, you start working from a concept stage and start doing simultaneous computer engineering. If you're using a different material, you need to also understand that what will be the stress area, what will be the kind of structural change which you require, how are you going to productionize it? Because any changes in your body in white or any changes in your assembly structure is going to also impact your production lines. So how is the supplier going to productionize it? So productionization is also another phase which goes on parallelly. So a lot of things in vehicle development do happen parallelly, so that everybody comes together, and then once you get into the design prototype stage where you get put everything together, then you start seeing the results. Then you start again balancing, optimizing things as things go forward. I hope I could answer your question.
Right. No, absolutely. And in fact, Dr. Sahu, you took up the point of CAE and, the design being a critical element, and how you also need to factor in different materials into, analyzing their behavior under stress and force application. And that was also a question from Mr. Sanjay Kumar. I'm just seeing from the Q&A box, and he was also asking about the same, on the role of CAE in terms of overall lightweighting activities. And also I want to touch upon, Priti, are we also looking at lattice structures or maybe generative design for additive manufacturing? Is that also playing a key role when we talk about the engineering methodologies being adopted for inducing lightweighting in vehicles?
So I will start with the CAE part. I'm not very much aware about the lattice part, but from the CAE part, I can surely can throw some lights. So CAE, as we discussed in the previous presentation, and also Dr. Sahu has mentioned about, CAE is a part. It's always with the design. So when it starts with the design, the CAE is the most important part to understand the boundary conditions. Based on the boundary conditions, every part has been developed. And for the lightweighting, CAE is the main ingredient, I can say, to win the situation, because it's all in simulation stage. You will get 90-95% of the results to understand how this direction of design is going on, and how are we testing. When you're going to test in the FEA level or at the part level, at the proto level, CAE is the one which goes up to the success. From the design post of material, you talked about the three-dimensional, 3D printing you mentioned?
3D printing, yeah, that's correct.
3D printing is at the proto level, it will be surely helping. I don't have much of idea on that part, at that particular depth of understanding on the 3D printing. But surely CAE as a design for lightweighting is a must. And it as it mentioned, it is an engineering work actually. So CAE is a must, and for materials or for the design of the car, everywhere it helps. As a material supplier, we use CAE in a big level, and obviously the same I expect from the OEMs basically.
Right, right. Dr. Sahu, would you be able to shed any light on generative design or additive manufacturing? Are we as an OEM, are you sort of deploying any of these methodologies at the engineering level?
Yeah, we do sometimes, 3D prototyping for many of our projects. I mean, not to a big scale, but yes, wherever we are working on new designs and want to see some of the things working, how does it work really, and how does it behave in certain ways, we do have quick prototypes made and then see how it is really performing in that situation. That we do, definitely.
Right. And if you can take some examples, Maruti has the Hardtech platform, which is, known to offer lightweighting attributes and, enhance the efficiency of the vehicle. If you can, just touch upon some of the key characteristics of Hardtech, what sort of materials you've used, and in terms of, efficiencies, what sort of improvements have you been able to achieve in your platforms and products?
See, when we talk about platform constitute of 3-4 major things when we talk about a platform. So like I was talking earlier, platform would be basically the underfloor, the front end, which looks at the crash performance of the vehicle, the crumple zones, and also along with that, the suspension, steering, the braking system, and we also include air conditioning in the kind of platform. Because when you look at dash, because that's basically the fundamental area which defines the vehicle, and then you can put different kind of top hats, and you can change interiors, you can change exteriors, and do different models. So modularity is one part of it when we talk about platform. Second is that in terms of performance, what we are looking at is that how does the energy dissipate when the crash performance happens. So that's primarily driving the basic body structure. And for vehicles, any vehicle, for example, if you take that for that matter, the most important part is that we need to observe the energy in case of a crash, and it should not impact the passengers or the occupants. That's fundamental aim of vehicle design, or when we are looking at vehicles for safety. So what has happened in our 5th generation platform, when you say lightweight, it's actually lightweighting, that the energy absorption paths have been defined in such a way that we have excellent crumple zones in the front. So somebody may think that in case of an accident, the front is getting crashed, but that's the whole purpose of it. So that, the person doesn't get any impact as far as the vehicle occupant is concerned. You imagine, for example, a case like airbag deployment when it happens. Suppose the dummy goes and so similar, when the crash happens, the crumple zone is the zone which takes care of. Am I audible? I think.
Yes, you're audible, Dr. Sahu.
Yeah, thanks. So the crumple zone takes care of the energy which is dissipated, and therefore the least impact is happening to the inside of the vehicles. And then when this becomes lighter weight, you are able to, the right weight other aggregates also.
I think there's some trouble in Dr. Sahu's network. So yeah, you're back online now. Yeah. Please unmute yourself.
Therefore, we are able to aggregate and optimize the other vehicle areas as well for performance. So beauty of our tech platform has been is that it has helped us in achieving a better fuel efficiency. Like I said, that's the first driver, which is also good for the customer and good for the environment. And it has excellent performance in terms of safety. And it has helped us build multiple platforms. I mean, multiple vehicles, products across the same platform. So when we talk about 5th generation tech platform, so it has helped us build SUVs, MPVs, sedans, hatch, meeting various customer requirements.
Right. So like we were discussing in the keynote, with Mr. Mamilapille, that even though the cost might look like the initial inhibitant in terms of adopting these alternative materials, but when it gives you the vast option of making different products on a single platform, I think it evens out in the longer run.
Absolutely, because your investments come down,
Right.
and you are able to capitalize on your investment, get much better return on investment, because you have modular platforms which can be applied across different vehicle segments. So
Right.
that's definitely one of the advantages which is there.
Right. Kriti, so like Dr. Sahu was mentioning, I want to understand from you. I mean, I don't know, I mean, if there is a myth already out there, in the industry, use of these alternative materials, if they're used appropriately at the right places, for example, the use of composites in the crumple zones of a vehicle, does it end up enhancing the overall safety quotient of that particular car?
Exactly. So, for example, take an example of body in white, as Dr. Sahu has mentioned. Also, the body in white design compared to the current generation and the earlier generations were having a very different level. Either it is from the NVH of sound absorption, or it is from the crash absorption part. Either it is coming from the metal design itself and adding a composite in the body inserts, for example, like body inserts, which helps in the delay of the crash to reach near to the space of occupants, basically. And that is basically one of the example of how the composites or engineering compounds helps to delay the crash, to increase the resistance of crash, basically, in a way. So obviously from a safety point of view or lightweight point of view, components surely helps. And it helps in the design perspective for safety and also for lightweighting.
Right. And Kriti, if you can also shed some light on, the different materials, if you just jump into the part of materials only, and you're a key material supplier in the space right now. So if you can just touch upon, what different materials is the industry looking at when we talk about the interior components as well as some of the exterior, the BIW parts of a vehicle.
So major parts when it comes to lightweighting from the performance basis, there are parts of lightweighting coming from aesthetics also. For example, the interior parts or the exterior, some of the parts are, for example, unpainted plastic part to be made from metal to plastics that are available in plastics in interiors, which may not be adding any high performance from crash or other part, but it solves the purpose for the look and aesthetics. For performance-based, majorly it's all engineering plastics like polyamides, or high temperature polyamides, or reinforced other polyesters or other engineering plastics, majorly are the main ingredient for metal to plastic replacements when it comes to lightweight. Body in white, it is basically polyamides reinforced with glasses. Different level of glasses are used mainly for body insert applications, or integrated approach like for the tailgate structures. A couple of new models of different OEMs with a completely integrated tail and gates, which are completely made of composite plastics, replacing total aluminum or high strength steel or normal mild steel. So that is one part for the body in white, I can say. Powertrain, we have various examples, right from cast iron steel engines to aluminum contemporary engines to now you can see most of the engine parts. If you open the boot, the underhood, you can see only black color plastics rather than less aluminum, less metal. It's all because of most of the aluminum parts or steel parts have been replaced. You take the air intake manifolds or cylinder head covers, 15 years back or 20 years back, it was all in aluminum. And now it is all integrated plastic parts, mainly in polyamides, cooling fans, thermostat housings, or the cooling circuits, basically total cooling circuit is in plastics. We have seen a lot of rubbers has been replaced by thermoplastic elastomers. So these are the great examples. So mainly is performance-based plastics, wherever there is performance to temperature, performance to crash or mechanical energy. And for aesthetics, couple of other materials, which like I said, non-paintable plastics or unpainted plastic parts to also solve the purpose of looks and also to solve the purpose like low volatile organics. Paintable plastics has solvent-based paints, which can be replaced with unpainted plastics with the same surface finish, gives you a good vehicle interior air quality. and you can also target the comfort and lifestyle of the product inside the car. So it's mainly the product to address powertrain. It is addressing the thermal, which is basically we call as underhood applications. Applications related to body in white or exteriors are mainly for mechanical energized based material for high crash or high tensile grades or high flexural modulus grades, and for interiors and exteriors mainly for aesthetic purposes. So it covers, it's automotive is from bumper to bumper, it covers a supermarket of raw materials actually, right? From PVC, polyolefins, polyamides, elastomers, paints, coatings, and everything. So it covers most of the plastics, but it depends on what you are prioritizing and which area of design you are targeting, basically.
Right. Dr. Sahu, Priti just mentioned, he took this example of the rear tailgate getting replaced completely, from the conventional metal to composite. And what characteristics of these alternative materials do come into the picture when you have to think about replacing conventional metals with these new generation materials for, reducing the weight of those particular components?
I think let's take the same example, and I'll take few more examples. Just to start with, let's say from the front of the car, we used to have, and in some vehicles we still have some, seat metal headlamps, kind of rugged headlamps, and even in our old cars we used to have. Those got changed to plastic. So what is the requirement? The requirement that it need to have the thermal stability. The requirement is that in case of a impact, it should not break so easily, but should break to absorb the energy, and it should be transparent. For example, the glass of or the plastic glass or the front surface should be clear enough to meet the homologation or the photometry requirements, and the reflector should be such that it is able to reflect the right kind of lights. So there are multiple of material. If you just take the example of a headlamp getting converted from sheet metal to a plastic. Similarly, we talked about the radiator fans. You have certain environment where it is operating 120 degree plus. So you need to have material which will be reliable enough, robust enough to withstand the life of a car and operate it smoothly. And the base being the plastics, then you have the motor, which is a running part. So it has to have the wear and tear resistance properties. Again, from structural point of view, it will be mounted in the front end. So how it will be structurally integrated, that's the kind of situation to be there. If you get inside, powertrain we already talked about in terms of air cleaner and in terms of other parts getting changed from either from sheet metal or either from iron parts to aluminum.
Yeah.
But you talk of NVH parts, for example. Earlier you used to have some kind of the NVH parts which insulates noise coming into the cabin, but we can have a different kind of lightweight material which is little expensive today, but can be much thinner, and therefore you can have space inside the vehicles as more and more space is getting eaten by different engine accessories. So that becomes another area of improvement. Similarly, inside the body interiors, we talked about so many things. And coming to the back door, I think first and fundamental, the door has to operate properly. When you're opening the door, you have the rear door holding mechanism. So the lighter it is better, so that customer can operate it easily from a customer point of view. But at the same time, it has to be robust enough, it has to be rigid enough and structurally sound, so that it's reliable over the life of the vehicle, as well as in case of a rear impact, something happens, the impact does not get inside the vehicle. So these are the fundamental requirements when we talk about changing of any material from material X to material Y. We need to look at the environment. We need to look at what kind of properties it need to fulfill: temperature, humidity, the energy absorption capabilities, and reliability and safety. All these factors are taken into consideration when you're looking at alternate materials.
Right. And you mentioned about the rear tailgate. I mean, is it also possible for the front fenders to also be replaced with some of these composites? or any other external part, bumpers are already, we've seen the bumpers getting transformed from the conventional metals. This has been like for a while now. But any other exterior parts you believe have the potential to be transformed?
It is possible. I mean, it all depends what kind of a exterior looks you want to give and what kind of a shape you want there, and what kind of energy absorption properties you want there. Composites could be one, but composites today are very, very expensive.
Okay.
For example, if you talk of fuel tanks have been replaced from sheet metal to plastics.
Right.
But if you talk of a CNG tank, for example, today,
yeah, I was just about to come to that. Yeah,
it is expanding today rapidly.
Correct.
But can we have a Type 4 or the composite kind of material? It's possible.
Okay.
It helps both ways. I mean, in terms of safety, reliability, there is no concern. What is the concern? Concern is manufacturability and cost. So today it's probably 4-5 times expensive.
Right.
Or 3 times expensive. And there are not many manufacturers in India who are doing it.
Right.
So for large scale adoption, we also need to look at how the material or the particular design can be localized with the right kind of cost, so that we are able to offer value to the customer. End of the day.
Correct.
Customer would not understand, okay, what is the right sizing we are doing or automation.
Exactly. From a layman's point of view, it doesn't matter, right?
Absolutely. So he's going to look at end of the day value.
Correct.
So if you're able to get help from suppliers and manufacturers who are able to collaborate and help develop composite materials for CNG, for example,
right,
that would be a great step for India.
And that is a very pertinent point that you've raised, Dr. Sahu. And Priti, so, what are we looking at in future? Do we see the cost coming down when we talk about particularly, let's take this example of the CNG tank. I mean, after the tightening emission norms, I think this is emerging as one of the key fuels for the Indian market. And there is huge growth potential in this going forward. So as a material supplier, if you can get your perspective about, how do we see the costs sort of reducing to allow OEMs to offer these, composite tanks when it comes to the CNG cylinders?
Yeah, I'll touch upon two things. One is the CNG part, and another is the flexi fuel, which is also very close cousin of this application. Yes. And as Dr. Sahu mentioned very clearly, is exactly one is what are the cars we are targeting, what are the models we are targeting. For example, A or B or C segment car. A D, I am doing a D segment car with all the innovations of lightweighting. Can be done in A car also, but are the people ready to buy? And no buyer is going to come and ask me, I want a plastic car or I want a lightweight car. They say, I want a car which is affordable either by efficiency or by user worthiness or longevity, better mileage, and I need a comfortable drive. Am I right? So nobody's going to ask. So understanding the customer needs, the OEMs, the manufacturers, people like us, we work together. Coming to a point of CNG and flexi fuel is, obviously, there is a cost imperative. Why I say there is a transformation from a diesel to a gasoline to an electric vehicle. And before this pit stop, there is going to be another pit stop, which is CNG or LNG or flexi fuel, because there is a transformation which needs time. The country needs to have their infrastructure ready. The people's mentality has to grow to that level. People are very, very buying nature is very, very picky now. Am I right? Everybody is very picky. But 15 to 20 years back, now the people are very intelligent to buy a car. You cannot sell a car to any person so easily today. Yeah, the buyers are very, very intelligent. They compare very well. I can already see some of the people already writing which are the applications going in which car. Yeah. Right. So coming to the point, CNG point is one of the major important point to address the CNG or flexi fuel is, one is cost, the running cost. Another most important thing is basically to address the pollution or emission. So obviously the cost part is very, very important. Whatever learned in the gasoline or diesel vehicle is getting used. And the plastic part surely will answer, because we're already working with the OEMs, for example, how a gasoline to a form E40 or E60 or E20, how the vehicles has to be designed, whether the existing plastic can suffice the same requirement of the powertrain. The other parts may not be the powertrain. The whole line which is going to handle this fuel should not be objected by the fuel for this application. So obviously the plastic is addressing this one. Wherever there is a need of change, it has to be done. But we don't see much issue on cost coming from the current to the CNG or flexi fuel, because we have already gone through a journey of 25 years in the automotive, last 25 years of development. And it is not a big challenge for addressing those points with a few optimization for few applications. Obviously, a new development or a short-term development is needed. And surely the cost is one of the main part, and it is getting addressed to the plastics or the advanced materials, basically.
And are companies like you who are into the material space, so is it like sort of becoming a mandate for you to localize some of these specialized materials going forward to allow the industry to reduce and optimize the cost of the vehicle?
There is no mandate for reduction of the cost. With the drive of the demand and the targets, obviously it is done. For example, 15 years, 20 years back, I'm not trying to take any brand, any luxury car model which is having all these technologies. Today, you can see in the A segment car already 80% available, which means the cost has been already addressed by all these technologies. As he rightly said, the cost of economics is the one which is driving everything. If I'm doing a plastic part for a 30,000 vehicle car overall year or just 3,000 cars, it doesn't make any sense, because what is the cost of return of investment for that? I want to make an injection molding tool for a 3,000 car for the whole year is not at all going to be, it's going to be a museum product. But if a 330,000 car is going to become a 300,000 model, obviously it will become very easy. So the cost of economics is driving that one. And the technology which has taught for the last 25 years is also trying to optimize. It's not only the material cost. There are a lot of technologies like operations, integrations, serial productions. So all these things are going hand in hand. And it is not only one or two layers working on this. There are 15, 16 layers working on this industry till it reaches the end of the customer. And everybody is doing their part on improvising the efficiency, and it is surely tapping to having a very good cost efficiency.
Right. Dr. Sahu, so, like Kriti mentioned, it's not just the material cost, it's sort of hand in hand with the other things as well. So if we can, touch upon this particular aspect of the challenge when it comes to shifting towards these materials. So manufacturability and overall procurement, does it become a challenge for OEMs when you think about, shifting towards some of these new generation materials?
It does actually. Like I said earlier, I think you have to begin with the end in mind. When we want to do X number of right sizing or looking at alternate materials, you have to look at what is the objective of this whole program that I'm doing. Let's take, for example, a CNG tank. I know I'm hypothetically, we would like to go for a CNG tank which is carbon fiber or the composite material. So at what cost can I do it? So I'll have a cost target. And does it, first of all, is it available in the sizes that I require or not? Is it available in India? Can it be localized? Then does it meet my strength requirements, my structural requirements, my fitment requirements? To start with the layout requirements. Then does it meet my durability requirements? Can I test some of these parts in a way which is advanced to the project, actual project, along with a supplier, and collaborate with him and work on it to look at that, okay, this could become a possible viable option for future. So, these are the things you have to start with. So you put all your constraints, whether it is engineering constraint in terms of the functional requirement, the appearance requirement, the structural requirement, the durability requirements, or it is a requirement of from a customer perspective, or the requirement from manufacturing perspective, and the requirement from the supplier perspective. So all these requirements, when you're putting it together and then looking at it, then you start evaluating how does it help or what is the pathway that we need to go ahead for the right kind of solution. Once, and you may not have answers to everything at the beginning of the project. May not. It's not possible. So you start doing some kind of advanced engineering work along with the suppliers, collaborate with them, try to find some answers, do some experiments, and then find some more answers, and then go ahead. I think that's the kind of approach which happens in many of the areas. Some of the areas which are known, like you were saying about B segment coming to A segment, those are examples of proliferation of technology. That okay, you have applied already applications already in higher segments, you bring it down to lower segment once the cost curve is favorable. But there could be other things where actually a D segment thing may not work in a A segment because of certain other constraint. So that's the right kind of application engineering there you have to do and look at whether those solutions will work or not work, because D segment vehicle may have a larger engine compartment, for example, and the operating environment could be very different. The temperature could be very different compared to a smaller vehicle where the engine compartment could be much more compact, and therefore putting the same material into a different degree of temperature. So you have to get into each aspect, each criteria of engineering evaluation. And like I said, it's internal engineering evaluation, product evaluation, customer evaluation, supplier evaluation, and overall, does it make business sense or not? So the things I think you need to look at when you're looking at automotive.
Right. Preeti, I'll just be with that thought only, and I'll also bring the whole angle of supply chain constraint right now. With the auto industry sort of being in a turmoil when it comes to supply chain over the last 2 years. So is it also becoming important for companies like you to finally sort of think at localizing some of these materials? I mean, is that also one of the drivers right now?
Yeah, that is always there. As you rightly said, supply chain is the main backbone of any manufacturing industry. Say it is for appliances, or it is for consumer electronics, or for automotive industry. It's very, very important for each one of the tiers to work on the localization part to make it more efficient. And it also depends on to what level it can be, because there are limitations from upstream and downstream to have localization, everything in the same place. It could be because of the infrastructure of the country, or availability of raw material, or other services, which could also able to avoid some of the raw materials upstream not makeable in the local part. But what I'm trying to say is, for the raw material supplies, yes, localization is one very important target, and also certain parts which are not available, but at least the supply chain pathway has to be in a better way compared to during the situation. Simple example, we can take the last 2 or 3 years, which has taught the whole value chain how this industry is so organized, in spite of, except for the chip issue or the semiconductor issue, which is not only connected to automotive, it is a much bigger industry. But other pathways have been well handled by right from the upstream to till the end of the car manufacturing. So to answer in a simple way, yes, localization helps, but not everything can be done because of the situations or the infrastructure availability. But localization supports really well. And I think the government of India's plan, like Make in India, is one of the best examples how the component manufacturing is proliferating in India today. And we are becoming a component manufacturing hub for a lot of OEMs today. And we are becoming an export hub for some CKD components going out of India. And that is obviously is one of the key factors to go to the next level. And we have examples of countries like Germany or China, which are ruling this industry for a couple of decades. And these are the basic reasons, actually.
Right. Dr. Sahu, your thoughts on this? I mean, now with the entire supply chain scenario that we've faced over the last 2 years, are you in your evaluations when you're looking at, evaluating or, finalizing upon a particular supplier for a component, has this become sort of a very important criteria now to also evaluate where the entire trail of the supply is coming from?
Yeah, I think, sure. I think as far as Maruti is concerned, we have been tracking the supply chain, real map up to tier 2, tier 3 since long time. Unfortunately, the chip shortage has been one of the major problems here. But otherwise, we look at where is the raw material coming from, who is the producer, and what kind of capacities they have, is it going to meet our requirements or not requirements. That's something we definitely evaluate, and it's very, very important because today everything is integrated. Something happens here at place X, you get affected. If you are not having a backup level, that's also something which is very important to look at. That suppliers having multi-location plants or multi-location supply is extremely important. Or it is also good that in India also, when we are looking at suppliers, looking at alternate locations is also one of the factors that we look at to have continuity of supplies. I mean, that applies to anything. It's not only the raw material or materials per se, it applies to anything.
Right. And with that, I'll switch to taking questions from our attendees, and we have a lot of questions coming in. So I'll just start with this particular thing, from Shriya Munan KS. How do you think the absorption requirement will be in the case to counter the high frequency noise of the electric motor? So I think the question relates to EVs, and with EVs coming into the picture and we moving away from conventional powertrains. So how does lightweighting in different materials play a role when it comes to the absorption requirement with respect to the noise generated by these electric motors?
So electric motors would have two kind of noises actually. One is a mechanical noise, and the second will be the electromagnetic noise. So it's a combination of both, and then you have different kind of filtering materials which are required. First of all, the motor itself has to have some level of specification that the noise level should not be more than this X, for example, X level of decibel or X level of electromagnetic noise. That's a fundamental requirement for electric. The second requirement would be that when you are looking at the vehicle structure, and then how do you put the noise insulation materials in a way that the noise is not impacting the occupants inside the cabin. That's the two ways actually to tackle the electric motor noise. I mean, just like engine noise also, is tackled today at different frequencies. There are multiple frequency noises which is comes into the vehicle.
Okay. Kriti, you want to add anything to that?
Yeah, surely. Yes, well, he has already touched upon most of the points. I just want to add, as there is an engine replaced by the motor, obviously the engine noise, structural board noise will be replaced, and there will be a minus. And obviously there will be a motor noise, which may not be at the same level, but there will be a road or a structural board noise from the road, which has to be handled in a different way. So as he rightly mentioned, the filtering material, which we call as insulation, or the carpet systems or the acoustic layers, has to be designed differently. The specification changes, then according to the specifications, those insulation material will be adapted accordingly. So that material point of view, that it comes from the design, from the designers, then that will be addressed basically. And we are working on those parts. So it goes hand in hand how the source of noise changes, then obviously it has to be designed changed accordingly.
Right. And I'll take the next question from Mr. Ashwin Kumar. So he wants to understand the application of carbon fiber. What all areas, are we seeing becoming more prevalent in carbon fiber now?
Carbon fiber is going to find some application in I'd say composite cylinders. You can have carbon fiber applications I had seen in some other places and countries about different exterior parts as well, where the impact absorption requirement is much higher, and it can be done, and it's lighter in weight. But again, I mean, for India, I think it's going to take a little longer time with respect to carbon fiber to get applied in vehicles, because the affordability is one of the critical matters. But it will find applications wherever there is a high energy absorption requirement, and it can be managed with the cost targets.
Sure. Kriti, you want to add a few examples to that?
Yeah, so major applications, obviously it is lightweight to the tenacity basically. Obviously carbon fiber addresses the point very accurately. But the problem is, like for the mass market, for the car manufacturing, it is still less at the level of penetration. For the aerospace industry, obviously it is one of the biggest usage. For Formula One sports car, because it is not for mass market, it's already used. For mass market, some of the applications are already using. Some applications like fuel filters specifically, they want to have an anti-static fuel filters which cut outs of the dielectric sense. Other parts they are using it, but not to the same penetration level. Structural application few, but there are a lot of other good materials which can address it in a much cheaper or a much cost optimized way. Right. Which is already doing the same job or in a much better costing level. So obviously there are a lot of chances, but any superlative applications probably will be addressing with the carbon fiber. But a normal mass market car, still there are a lot of good materials. But it cannot discount any carbon fiber penetration. If there are some applications which are very much only can be done by carbon fiber, should be addressed from that point of time. So see, engineering is an evolution basically. So it captures with the demand and the what type of constraints you are putting into the design space. then obviously this can be one of the biggest chances.
Right. And I'll take the next question from Jan. It's a very pertinent question, Dr. Sahu. So, vehicle speeds are increasing every year with evolution in the car designs and the performance of these vehicles. So we're also able to see the capabilities of these cars getting increased. Does vehicle lightweighting also affects the stability at high speeds?
Fundamentally, that's why I started my talk. I said lightweighting has a very different connotation, and people will look at it in a very different way, or I would say negative way, that if you're doing lightweighting, you're compromising on something. Once again, I'll come back to the same statement. It's about right weighting. And when you are doing lightweighting in the vehicle, you do look at these parameters. I said, like whether it is reliability, whether it is safety, whether it's ride and handling. For example, fundamentally, if you're reducing the weight of the vehicle, the CG will change, and therefore it will affect ride and handling. What extent depends on what level of change you are doing in the vehicle platform and other aggregate systems. So when you're doing that, how are you adequately taking care of that in your engineering evaluations, or tuning of the systems in such a way that it does not affect to the desired speeds at which the vehicle is supposed to travel? The vehicle speeds are increasing, but almost all the vehicles today which are available in India, designed to go beyond 140, 160. They have their own speed limits, and they declared speed limits for each category of vehicle. And those category of vehicles, and I think each OEM takes care to ensure that when the customer is traveling at that speed, it does not impact those vehicles at that speed.
The dynamic aspects of the vehicle.
Absolutely, the vehicle dynamics aspect is a very, very fundamental requirement of vehicle design.
Right.
Without that, what is the vehicle supposed to do? Vehicle is supposed to move people from point A to point B. And what are the three fundamental functions? Start, stop, and turn.
Right.
So these three fundamental functions are the three fundamental core engineering principles which are taken care when you are talking about vehicle design.
Right.
So how do you start it from, for a point of rest?
Yeah.
How do you handle it, steer it, turn it, which includes all your dynamics aspects, and then how do you stop it, which includes your braking aspects. And the three fundamental physics principles also, which are looked at when we are talking of vehicle design and engineering.
Right.
So lightweighting, when it is done, all these aspects are taken care of. As far as all OEMs are concerned, I think there should not be any worry that because speed is increasing, the vehicle would be stable or not stable. I think we should not mix those 2 points.
Right. Right. While Dr. Sahu has, taken care of the passenger vehicle side, Priti, I would come to you with the same thing, for the commercial vehicle segment, which is also the question from Mr. Sanjay. So what impact does lightweighting have when we talk about the commercial vehicles, the heavy duty trucks or the light commercial vehicles?
Obviously, because when it comes to mobility, it's also the same efficiency part. Lightweighting is also very, very important. Longevity and integral models. For example, you take a 2-tonner or a 4-tonner or 10-tonner vehicles. There are a lot of lightweighting aspects which are also going across in the mass market of the commercial vehicle. But the penetration of the commercial vehicle is different to a passenger vehicle. The reason is passenger vehicle mass market is much, much bigger than commercial vehicle, and the demand from the commercial vehicle is in a very different way. May not be all the metals or all the other heavy materials are getting replaced in a commercial vehicle. You cannot change the truck bay or something which is carrying the weight, which could be the same wooden part, or maybe it's changed into a aluminum or a steel rod. But the engine parts, a lot of parts has been already changed. The oil pans, the cylinder head covers, the cooling fans, the radiator chains, those are the powertrains which are already been changed. And the drive for the lightweighting is still against the efficiency. You see the noise level of the trucks compared to the earlier generation trucks also has changed. Buses, you have seen much smoother buses, even in the indigenous made buses in India also have become much smoother, much adorable compared to the old one. A lot of structures has changed. The seating systems has been changed in the buses compared to the old one, and also the air conditioning efficiency. There are a lot of lightweighting insulations goes into an AC buses, which are not visibly outside seen. Earlier, it used to be a glass wool or other things are getting used. Nowadays, spray foams and other high efficient insulation materials are going in situ, which have been designed in the bodybuilding of the bus. So commercial vehicle also attacks the lightweighting, no doubt, but the penetration level and the priorities are much, much different. But on the powertrain part, yes, interior parts could be little different for a truck and a bus. But if it is a load carrying member, may not be a much different from the load carrying side of the body in white, because the purpose of load carrying never changed. It's the same load action. Yeah. So that's what we have to address, those parts. So, the answer is yes, but the penetration levels and priorities are different.
Right. And before I take the final question, I'll take one more question from Priti. You had mentioned about downsizing of the engines as one of the key parts of key ways of reducing the vehicle weight. There is a question which asks about does that inhibit the overall longevity or the reliability of the engine? Dr. Sahu, would you want to comment on that? I mean, downsizing the engine, does it impact the overall life or the performance of that particular powertrain?
The answer is no. Very clear no, because when you are downsizing again with certain objectives in mind. That okay, how do I make my engine perform to the requirement of the customer first of all? Okay, he needs certain level of performance, he needs certain level of drivability, he needs certain level of acceleration, and therefore these are the fundamental requirements we have to meet. At the same time, when we are downsizing, does not mean that we are compromising on reliability or any other factor of the vehicle. An engine or IC engine per se, I mean, from that perspective, it's supposed to last the lifetime of a vehicle for the customer uses. So whether it is downsized engine, which is in terms of cubic capacity, but with certain other additional technology can provide the right kind of performance, has to meet the kind of durability requirement. There is as such no compromise. So downsizing or lightweighting does not mean it's compromised things. Actually, these are actually optimization equation parameters, not a compromise equation parameter.
Right. And with that, I'll just take your final closing thoughts from each one of you, starting with Kriti first. And that also is a question from Mr. Ravi Teja Danda. So, going forward, gentlemen, do you believe that regulations are also going to drive the industry towards making vehicles more and more efficient? And that is why this need for making lightweighting sort of an intrinsic part of your engineering? Or do you believe that the industry is sort of now voluntarily driving more, that on its own it's sort of gained that momentum to keep evolving and innovating on this particular front?
So I'll go first. So regulation goes hand in hand with the industry. And you should understand one thing: these regulations are done for our goodness, basically. Today, what we are going through, the natural calamities or something which has been taken COP26 or in the global climate controls and other part. So this is basically all these compliances and regulations are coming to safeguard our home, to save the earth from all these issues. So regulation is one, obviously is an accelerator or is a trigger that helps hand in hand to go with the industry's development and demand. So as rightly said, demand is the king of mother of all the innovations. And this demand comes from these regulations. And simple example is today, e-mobility drive compared to 5 years in China and now, why it is basically driven, it is not because that they want to have e-mobility. The government of China wants to develop it because they want to reduce the forex, the foreign exchange towards the self-sufficient electric mobility rather than buying fossil fuel from Middle East. And today you can see around 5 to 6 million of electric vehicles are manufactured and sold in China, which is our total production of electric vehicles, passenger vehicles in India. So regulation is going to be the biggest driver for all the innovations and lightweighting, and it has to go hand in hand. And as rightly mentioned by Dr. Sahu, any engineering design is without compromise. When you say engineering design or lightweighting, when you say a car is a car 50 years back and now, and in fact it is evolved more and with all more safety conditions and efficiency, without compromising any of the boundary conditions, these designs are done. And lightweight will keep on doing this in demand for those aspects. Thank you.
Right. Last word to you, Dr. Sahu, your outlook about, your gaze into the future. How do you see lightweighting continuing its relevance when it comes to engineering of vehicles in the future?
I would say that the developments in the past few decades, not only in India but globally, actually has put this right weighting in the right path. Like Newton's first law says, a state in motion will remain in motion, and a state at rest will remain at rest until it is disturbed. So whatever has happened, the three driving forces, like I said, globalization, customer requirements, and the increasing requirement of CO2 reduction, has put right weighting at the given the right impetus. And therefore, this is going to continue and evolve much more as we go towards the path of alternate mobilities, alternate fuels, whether it is CNG, where the weight is again going up. I mean, you need to optimize there the requirements, or it is flex fuel, or it is hybrids, or it is electric vehicles. In the transitory path of automobile industry towards the future, I think right weighting will remain on the right path. That's my concluding thought.
That's very well summarized as well, Dr. Sahu. And even though we are getting a flurry of questions, I can see down here, but we have completely run out of time. I hope both of you enjoyed this conversation as much as I did. And, I hope the audience has a lot of takeaways from this. And we had a good and all-encompassing chat on lightweighting in the automotive industry right now, and how the industry is progressing by taking this engineering methodology in the coming future. Thank you so much, Dr. Sahu and Mr. Pritikumar. Thank you very much for your time.
Thank you very much. Thank you.
Thank you. Thanks a lot.
Pleasure.
Thanks.
And with that, I would like to hand it over to my colleague Shakar Avidi, who will take us forward with the presentation session of the day. Shakar, over to you, please.
Thanks, man. Now I would like to introduce Mr. V. Naresh. Naresh is a graduate from Central Institute of Plastic Engineering and Technology and has accumulated over 18 years of experience in the polymers industry. His knowledge spans across product design, mold design and development, process optimization and application development for automotive. He was also part of the Global Techno Push program in Solvay, working on identifying the applications and market potential for high temperature resistance polymers. Naresh is currently leading the technical development for engineering plastics performance materials at BASF India, and will be giving his presentation on lightweighting and system integration through PU composites and engineering plastics. I would request the audience to kindly send their questions in Q&A box, and I will take them up with Naresh at the end of this presentation. With that, over to you, Naresh.
Okay, thank you, Mr. Saha, for introduction, and thank you the team for giving this opportunity. Yeah. Okay. Hope team could able to see my screen, so someone confirms so that I can go ahead.
Yes, we can see it.
Yeah, that will be great. Thanks, sir. Okay, the topic which I will take you through the next 15 to 20 minutes is the lightweighting and the system integration. So how from last few hours we have been having intense discussion and insightful questions from the team on the lightweighting topic in automotive. So I will just take you through some of the co-creation exercise which BASF did across the globe on the subject of lightweighting. And when we talk about lightweighting, system integration has come along with it. So we have a successful journey in developing the products and applications in automotive on this particular area of lightweighting. So I will take you to the presentation. Okay, so the agenda will flow. I just give a small introduction on BASF, and then I will share some of the co-creation applications along with the case study, how BASF will work with the customers and OEMs and tier ones to create the innovations on the lightweighting subject. So BASF introduction. BASF, we create chemistry, and our chemistry is there in almost all industries. And we are being a market leaders in the chemical industry. We have a responsibility of economic success and environmental protection of the globe as well as our customers. And as a company, we have about 78.6 billion sales net and with EBIT of 7.8 billion euros as on 2021. More than 111,000 employees working across the globe. We have 6 urban sites and 332 manufacturing sites across the globe, out of which 8 manufacturing sites we have in India. And when I say 6 urban sites is nothing more than most of the integrated manufacturing plant, where one of the manufacturing from one of the output of the manufacturing plant has been used as a raw material for the other manufacturing unit within the same campus. So that way we could able to create more integrated and self-sustainable product development. So that is one of the key strengths of BASF, where we have most of our products we have been complete backward integrated, so we will be sustained in terms of the material availability and the supply chain point as well. And R&D is our key focus and strength, where we spend more than 2 billion every year on the R&D, developing the new materials and creating the new chemistry. Across the globe, we have 90,000 customers with the various sectors being present. So when I say we are a chemical company, we segment in 6 verticals. Starts with the chemicals, where it is a core which as a petrochemicals and intermediates. Most of the time this is a raw material for the other segments. And then materials, in materials we have performance materials and the monomers is most of the base polymers, and for performance material is the engineering plastics and polyurethane solutions, which we will discuss more in detail in the coming slides, which we are presenting today. And then we have industrial solutions on the pigments and the performance chemicals. And then surface technologies, majorly on the catalysts and the coatings, paintings, and then nutrition care and agricultural solution. If you could able to see out of the 6 segments, 3 segments has been closely working with the automotive business. That starts from material, industrial solution, and surface technologies. So we'll see more detail on the performance materials, what is our products and how we have been supporting customers on the innovations, especially on the topic of lightweighting. So performance materials, this is our material portfolio. We have polyurethane systems. In automotive, it's widely currently used in the interior segment, but with the change in the shift towards the EV, we could see there is a lot of applications where we could able to support our customers in the battery thermal management and encapsulation and the lightweighting with the polyurethane systems. We have benchmarks and success stories around that. And we have thermoplastic polyurethanes, which is a very good soft skin material with much higher durability compared to the solutions like rubber. And then it is also having a very good weatherability and resistance to oil, grease, and low temperature impact resistance. And then we have PBT. Ultra-Dur is our product range. PBTs is widely used in the electronic components, and the where the dimensional stability is key, and then have a very good electrical performance and a good dimensional stability along with the low water absorption behavior. And then polyamide and the PPA, polyphenylamide, where we have a high temperature material which has been very good in terms of its mechanical behavior. Along with the chemical resistance, polyamide has been known for its chemical resistance with the contacts and a low tendency to creep and outstanding chemical resistance along with the good heat aging behaviors. The material property retention after a long aging at harsh environment, either in the chemical or air, whatever it is. So those stringent applications, especially under the hood, the polyamide has been widely used for the applications what we have been discussed so far, like underwood, cylinder head covers, air intakes, cooling pipes, cooling tanks, kind of. And then Ultraform is our polyoxymethylene solution. It's majorly used in the wear resistance applications and the fuel contact applications. Form is known for its good tribological performance along with its chemical resistance against the fuel at the low temperatures. And ultrasound is our specialty polymer, where it has been widely used in the membranes and high dimensional stability heat resistance application. We are talking about continuous usage of more than 200 degrees Celsius with the good flame retardant properties, along with the hot water resistance, where it's also widely used in the medical applications for the sterilization applications. And Basetec is a foam, specialty foams from our portfolio, which has been specially developed for NVH applications, where it will have a good sound absorption and the fire resistance. And it is also have a resistance to the chemicals and its eco-friendliness. So this is about the product portfolio of performance materials from BASF. And finally, while I'm introducing BASF, I have to touch that the part of sustainability. We create chemistry for a sustainable future. This is a slide where we probably say we have been working on the sustainability part for quite some time. Compared to 1990s and to 2020, last few decades, we have increased double the production rate from what we used to have, and we reduce off of the CO2 emissions from the manufacturing of these products. So whereas we have increased the production, but we reduce our CO2 emissions, and we have a target, stringent targets to work on towards like reducing further 25% by 2030 and reaching the net zero by 2050 with the products. So for this, we have been continuously working on our process improvements and operational excellence and shift to the CO2 neutral powers and portfolio developments around the bio-source materials, recycling, chem recycling. So there are a lot of activities going around the metal development to achieve the sustainable product to the customer, to deliver the sustainable product to the customers. So this is about the introduction of BASF, and now I will take into the session on co-creation activities, especially on the lightweighting and system integration. I will here introduce the applications where to give a thought this is possible, and for the team here, so that you can think, we can think, and we can take it to the next level. So it is just to show these are the already possible, and we have more to think and more to come. Before getting into the lightweighting, I just like to share this is one of the key key shift happening from the material perspective, especially the e-mobility, the electric vehicle drive has opened up a lot of challenges and new requirements to the new applications, and the market has been made with the new products. Especially we talk with the flame retardancy, that traditional automotive applications will sufficient with FEM VV30 standard flammability, but now the flammability requirement of most of the e-mobility applications has been taken to the next level of UL V0 5VA. So it is keep on increasing and getting stringent. And also the orange color, which especially to indicating the high voltage applications. So it is getting like a new black for e-mobility, the orange color seems to be. So this is kind of a new requirements we could have heard from the market. For being a metal manufacturer, this is one of the key for us to think and develop our material portfolio towards this direction. And then we also see the requirements of EMI shielding in the BMS and surrounding applications and controller applications. And we also see a lot of thermal conductivity material requirements in and around the batteries to manage the to control the thermal management on the battery cooling efficiency. So this all towards the metal development, which we are now focusing and developing the products around these areas. And the next part is lightweighting. Lightweighting is a key for automotive all this time, but with electric motor coming in, it will be taken more aggression. And as team has been already explained, in electric vehicle, reducing the weight is increasing the range, and which is a very key for the success of e-mobility today, to give the long range vehicles to the consumers. So this is an area where we are working in collaboration, because lightweighting is not only the product, it is also the design. As team has been already explained in the previous sessions, it is design and the collaboration playing a major role. So it's not only the material, and it's also the OEM and the tier ones who has to collaborate together to identify the right design, right process to make the lightweight possible. So that we will discuss in the coming slides. And then another requirement of high performance insulation materials. So these are the areas where we are currently working on the metal development. And lightweighting is the one area where we are closely collaborating with the OEMs and tier ones to effectively achieve the innovation in success. So this is one of the application where battery back cover, front cover, where traditionally it has been started with casting, and then it has moved to evolution of sheet metal, and later it has been with the force of lightweighting from sheet metal to SMC. And recently we had a success in converting the SMC to the PU composites. With PU composites, we could able to optimize. We have a design freedom to optimize the thickness from a traditional of 2.53 mm to 1.52 mm thickness in the sheet, in the back cover application. Along with, we could able to increase the fiber matrix up to 50% based on the strength requirement, and we could able to localize the strength requirements with the composite matrix when we have been using the PU composites. So this gives a customer advantage of 30% lower in comparison to the SMCs, which will also meet the similar requirements of the flame retardancy. We developed a special composites with the V0 flammability, which has been key requirement for this application. And then with the composites, the dimensional stability is much better compared to the SMCs, so which will help the good sealant performance, and also the productivity has been increased compared to the SMC technologies, and it is more stable, and it is meet all the application requirements. So, for example, this is one of the part which we successfully get through for this application, which has been tested and proven with all this tests like thermal shock, gas tightness, especially on the leakage, and low temperature impact behaviors, and the climatic cycling tests, burning tests, and the thermal hedging, deformation test, and vibration test with the complete battery loads, and the water leakage, bus pressure test, and most importantly, the thermal runaway behaviors. So all this test has been performed, and it has been get through. And this has happened because of the collaboration with the OEM and the manufacturing processor and the metal manufacturers, when we all joined together and we wanted to innovate and wanted to optimize from what the existing level is. So that is where this application is moved and went to success. And I will take you to the another example on the site with the similar passion with engineering plastics. So here from morning, Mr. Venkat also said, seat is a one area where currently we have more weight and we have to looking for optimize it. And the same discussion happened even during the panel discussion with Mr. Tapan. So this is one area we need to work on. So here we are come up with the success for the backseat, rear backseat application, where we converted a frame of backseat into metal to plastic, sheet metal to plastics. Here the biggest challenge is the cost. Whenever team comes up, they always put up the cost of sheet metal compared to plastics is challenging. But today we could able to make it, and we already have a success around this. And thanks to the new generation materials, which we developed the CR series, which is crash relevant series. So we have been used polyamide 6 35% glass reinforcement with the new generation crash relevant advanced formulation material. The advantage of this material is it's an ideal combination between the strength and the toughness, and this toughness part helps the high impact behavior to absorb more energy in case of crash requirements, and it's even good dimensional stability at a low temperature with a good creep strength. And finally, this has been made out of injection molding process, which is mass manufacturing process, which is quite easy when it comes to the processability. So here is the outlook how it is from when it is being converted from metal to plastics, especially when it is a sheet metal, when we are comparing to the plastic composites. So there are 16 components in metal which has been converted into one shot plastic with a small metal insert, especially on the mounting locations. So this is the area where which optimize the cost. So it is not, we have to see as an overall system, as the cost of the overall product. So here we have been optimizing the multiple process getting into the single process and the multiple tooling getting into the single tooling. So which will give the customer the cost impact, absorb the cost impact which has been coming from the composites compared to the traditional sheet metal. So this is on the cost front, and in terms of weight reduction, it will reduce more than 30% of the weight from the traditional metal application, and we converting into plastics. And the application, which has been again a successful application, and it's first in kind in the industry with this kind of a plastic standing seat backs. So it is not relying on metal brackets; it's full of plastic, and it is meeting all the crash requirements. It has been passing all the FEA requirements when we supported during the development, and then it is also physically made and tested and passed through the requirements. So thanks for the new generation and the new developments happening in the material front. So that is where we could able to develop this new crash relevant series materials, which will absorb more energy along with this good stiffness and the strength. So these are the co-creation applications to show the team this is possible, and we can work together to make the things differently, better with lightweighting, with the plastics and composites, and how we work together. So that is the area where I come up with this case study, especially when we discuss about the new ideas and we come up with the new innovations. So we need team to collaborate. Being a metal manufacturers, we know materials and how we could able to work and identify the applications along with the tier ones and OEMs. So this is the areas where how the typical metal to plastic or a lightweighting application development will happen. So starting point is the idea or the concept which we have to work together and identify, and from there we will define the space, defines the design space, what is the surroundings of the particular part or the objective we have, and how we could able to integrate the best possible. And we have to clearly define the objectives and the boundary conditions, which is one of the key when we have been converting this metal to plastics. We have to clearly define the boundary conditions. What are the key requirements of the application need to be taken care when we have been converting them from X to Y. So that definition is a key part which we have to arrive after we design the, after we come up with the idea or the concept. From there, we will go for the next step. For the selection of manufacturing process, how we are going to manufacturing this, and what kind of the material need to be used based on the manufacturing process and the application need. With this, we redesign the part according to the manufacturing process and the material to be used, because the metal cannot be converted into plastic assets. So we need the metal processing and the plastic processing different. So we need to optimize the design of the part based on the manufacturing process as well. So there we need to go for a redesigning and remodeling, and then this has to be taken to the FEA, CAE. This is a major area where it has been contributing the success of this metal to plastics or the lightweighting applications. So this is an area where we closely work with customers on the process simulation and the structural simulations based on the boundary conditions. And we do multiple iteration of optimization to get the desired part with the right weight, with the right specifications. Once we pass all these requirements in the CAE, the simulation frame, then we go for a proto to prove that this will be work, and then we will support again the customers with the lab testings. We do have our internal labs for part testing, especially core area on related to the plastics like thermal aging, thermal shock. So there is various vibration tests. So we could able to support customers on validating the parts in those kind of tests related to the plastics. And then once we prove these testings are related to the DVPs, then we will go for final freezing the design and getting into the mass production. So this is a typical cycle where we closely working with the customers on the metal to plastic approach, and which are the areas where BASF come in and support customers in this kind of development approach. We start work with the OEMs and tier ones from the concepts phase, and we start supporting or interacting with our customers on the design concept, especially when it converts from metal to plastics. We are supporting our customers on plastic design requirements and how to change the structures, so part structures to achieve the similar level of stiffness what we are getting from the metals. So this is an area we start work from the concept phase. And when it comes to design phase, we closely work with customers on selecting the materials and the specification requirements from the application point of view. And in the proto phase, we do the structural simulations and the process simulations based on the customer design, and to prove that the design what we are developing will meet all the requirements. And then after the proto development, we support customer on the part validations related to the particular application related to plastics, part test related to the plastics. And then finally, during the production, we again supporting the customer on the process optimization and closely work on closing the loop, ensuring it's a smooth transformation from the proto to mass production. So this is the areas where we closely work with customers in the co-creation and the innovation projects. And one of the case studies, what we have done with the customers is the motor mount, electric vehicle motor mount. So this is the inspiration from the IC engine mounts. So BASF is pretty strong in such applications when it comes to chassis or metal replacements. So we already have a good success stories in IC engines with more engine mounts. So when the e-vehicles come in, we wanted to take this aspiration to convert the motor mounts also into plastics, and with that we could able to make it the e-motor mounts in plastics. So it starts with the design space, and then we optimize the design, and we were, after finally arriving the plastic design, we do the process simulations, and we capture the process variations, and we do the structural simulations accommodating the process variations. This is one of the key strength of BASF, where when CAE comes, especially for the plastics, we need to capture the process, the variations, and the process outcomes when we have been doing the structural simulations, especially the fiber orientation and the well lines. All these factors has to be taken care while we have been doing the structural simulations to identify a real-time failure criteria. So that we will do with our ultrasim, which is, we call it more integrative simulation approach, where we do process from process, we capture process simulation, we capture the fiber orientation. From fiber orientation, we apply the mechanicals, and then we perform the structural simulation to get the correlation very close to the real-time paths from the simulation activities. So this is one of the core strength of BASF in the CAE, where we have a team working in India supporting the customers on these activities, from the design optimization to process optimization, and then process simulations, process design validations, and working on to achieving the targets. So with that, we could able to achieve more than 40% of the weight saving in this part compared to the metal. And we call better thermal and thermal management and the NVH compared to the metal. The one of the key reason being a plastic, it's an insulative material, it will not transfer the heat generated from the motors to the body parts. So that is where it has been more thermal management. And with plastic, the acoustics we could able to improve, and with this absorption behaviors, so the material will absorb the NVH, the vibration controls, compared to the metals. So it will also help to reduce the noise from the motors. And excellent mechanical properties even at high temperature, including the low tendency to creep. And with the advanced simulation, we will fulfilling all the safety related requirements, especially the static, vibration, and crash performance. We could able to simulate and optimize the design according to the requirement, and will meet the end objective. And so with this, we could able to identify the right material. Again, in this case, we used PA66 50% glass reinforced material with our CR family, CR generation, which is more on the crash observing crash relevant material series, so which is ultramad A3WG10 material. So this is a case study. I just wanted to share the team here so that they could able to see which has been possible for a lightweighting, as well as more of the stringent mechanical requirement part, which we could able to convert into plastics with the right design and with the right approach. So with that, I come to my last slide. So BASF is not only being a metal manufacturer or metal supplier, we wanted to closely associate with our customers as partners in innovation. To do so, we have our own processing center for polyurethanes, and then we have experimental part validation lab, which we support customers on the part validation related to the plastic behaviors. And our material consulting is most of the creation center. What we have so we brought all the BASF products into under the one roof, and there is a lot of there is designers and engineers working here, and we collaboratively work with OEMs and tiers in this under this creation center to identify the applications and also identify their unmet needs and how to solve those unmet needs with our material portfolio. Are we developing a new materials based on their customer unmet needs? So this is an area of activity happening in our creation center, which we have in our Mumbai, India headquarters. And we also support customers in the processing technologies, various processing technologies for engineering plastics, processing and joining technologies of engineering plastics. And we have in-house simulation competencies where we have experts working on the design validation and the design concepts, closely working with OEMs and tiers on developing the parts in plastics. And finally, the info points, we have different info points, ultra info points, PU and Elastron. So there's all the info points will more of the customer interacting points where customers can directly go and put their queries, and they can get the feedback from the global team based on their material queries and the properties data required from material front. So that's all from my side. Yeah, Sahar, you can take it up for questions.
Thanks, Naresh. Very insightful presentation indeed. And now we have a couple of questions for you. So I will be fielding. The first question is, how does the EMI or EMF shielding done in the PU composite battery cover? If you can just provide some elaborate details on it, that would be nice.
EMI shielding, right?
Yeah.
So yeah, here PU composites is more of the insulation with the existing one what we have been developed, but with the formulations getting placed, we could able to develop the with the EMI shielding as well. But most of the time, what we see the EMI shielding has been mostly required around the applications like controllers and BMS, where it has been addressed by engineering plastics than the PU composites.
Okay, and if you can throw some more light on your R&D activities here in India, and you said it's located in Mumbai. So if you can throw some light on it, what kind of staff strength or what kind of research is being done, especially on the lightweighting, and especially concerning the Indian OEMs in mind.
Yeah. We have a creation center in India, so it's more of a creation center where we have people working from the design concepts, and we have engineers working on the material, engineers working on the mechanics, and also the doctorates working on the chemicals. So here it is more the input center. So we will collect the inputs with the from the customers, and we will most of our R&D is happening either in China or Korea for the material development. But the creation center helps us to bring those connectors with the this R&D centers.
Thanks, Naresh. Thanks for all the input and for all the insights. Now I would like to hand over to my colleague, Mayank. Mayank, you can please take it up.
Thank you very much, Mr. Naresh, and thank you, Shakar, for moderating that technical presentation. And with that, we'll move to the final session of the day, which is a one-on-one interview session with Mr. Rajiv Bajaj, who's the MD of Stratasys India and Southeast Asia. Stratasys is a company which is into 3D printing, software, and materials. Rajiv, welcome, and thank you for your patience for waiting throughout the whole event, the proceedings till now. And I think you've been in demand today, and we've been getting all those questions about generative design, additive manufacturing, and 3D printing when we're talking about lightweighting. So it's good to have you on here with us.
It's a pleasure. Thank you very much for having me over, and it was quite an insightful discussions early on. So good learning in the process.
Right. So with that, Rajiv, so I want to get your perspective about how additive manufacturing is sort of playing its role when we talk about lightweighting, and if you can give us a sort of a broad scenario right now, a reality check when it comes to the progress or where additive manufacturing today stands in the global scheme of things when we talk about vehicle lightweighting.
Sure. So let's take a step back and first of all understand where all additive manufacturing in the automotive industry and automotive production is helping. So right from prototyping to jigs and fixtures to end-use parts, additive manufacturing provides great design flexibility. It provides lightweighting options, and it provides definitive cost advantages. Now, the beauty of the technology is that it can help you produce intricate designs, which don't need any toolings. Otherwise, it becomes very expensive to make certain organic designs. It helps you achieve better performances on the parts that you design. And of course, it enables you to do part consolidation. So in effect, you could possibly consolidate 25 assembly into a 5-part assembly, thereby reducing the weight and increasing the performance, and also reducing the cost. And of course, in almost all cases, it will eliminate the tooling requirements, because by the virtue of way it manufactures parts, you don't need any toolings, and what you get in hand is the final end-use part or a prototype, as the case may be. So come to lightweighting. Automotive industry has been much before the requirements for EV has been struggling with lightweighting because of the mileage requirements in the past and range requirements today. So combining the tools that we have today and the entire additive manufacturing ecosystem, starting from materials to machines to software that are available, it gives a very holistic overview on how you can actually lightweight certain integral components that go into electric vehicles.
Right, and is this technology also gaining more and more momentum in terms of not just being restricted to prototyping? Now, are we seeing the application of additive more at the mass production level as well?
I wouldn't say mass production, but yeah, definitely up to series production level. If you look at how the technology is transforming, a lot of focus since the last few years have been towards the choices of materials that are available to customers. Now, automotive industry by nature would need very high end specifications of materials, materials that are certified for use in certain specific requirements, and how exactly you can have high performance materials that could give you flame, smoke, toxicity kind of possibilities, especially when it comes to places like EV and battery design. Also, it has been a long-standing requirement of the customers to ask for open source materials on additive manufacturing technologies, which essentially means that a customer can program his own material and his own material choices for the end-use production parts that they will need.
Right.
Also, sustainability has become very important.
Exactly. I was just about to come to that. You've been sticking around since the start of the event. So, we heard Mr. Venkatram of Renault India talking about sustainability being a key driver. Then also we had similar opinions from Maruti Suzuki as well as BASF. So is that also one of the key driving force behind lightweighting and behind the use of technologies like additive in the automotive industry?
You see, sustainability is actually a requirement of today. There were days when you would say we need to create a better tomorrow, but there is no such thing as a better tomorrow. We need to create a better today. And that starts from all of us. So starting with a company like ours, which is a leader in additive manufacturing, we are the founding member of Additive Manufacturers Green Trade Association. And certain components, certain materials that we work with is a specific material called, for example, PA11, popularly known as nylon, which is 100% bio-based, and it is derived from sustainable castor oil. And the India Connect for this material is that 60% of the world's castor oil is produced out of India. Now, this material has high ductility, it has high impact, and it is very useful for cabin interior parts, under the hood parts, connectors, and a lot of high yield components that you would look at. So coupled with multiple other possibilities, sustainability is now becoming an integral part of our initiative. And the second part is that Stratasys as an organization is working very closely with material providers like BASF, Covestro as a company where we recently acquired their additive manufacturing business, companies like Evonik, where we work collaboratively with them to develop new use cases, work on sustainable materials, and give customers the kind of solutions that they would look for, both in terms of lightweighting as well as other requirements for the EV industry.
Can you elucidate upon some of these solutions, Rajiv? You're talking about materials and you're talking about overall process, like you're talking. So is this going to be an isolation additive, or do we have to look at the entire ecosystem? Talking about the materials, the design, as well as the process. So overall, if all these three come together, so then it makes more sense for a manufacturer or a design center to sort of adopt additive manufacturing technologies?
It's an excellent question. In isolation, additive, or in isolation, the regular conventional manufacturing processes will not be as effective as they would be in conjunction with a design software, with an analysis software, being connected to MES systems, and so on. So if you look at the additive manufacturing system itself, starting from the materials that you would use, to the design capabilities that customers would look at in terms of designing on the software, then getting into generative design, topology optimization, getting into conflicting use cases. For example, Ford designed a plastic bracket which replaced the steel bracket, where they not only reduced the weight by 40%, but also reduced the cost by increased the strength by 60%, and also reduced the cost. Now, these tools in conjunction will work very well to give a complete solution outcome to our customers in the automotive industry. And also the way the machines work, how well they are connected with the MES system, how cost effective they are. And last but not the least, a skilled workforce, which knows both the traditional processes as well as design for additive manufacturing. Typically, what happens is a lot of people think that additive manufacturing is here to replace conventional manufacturing, but that's not going to be the case for near foreseeable future. What we will see is that both these technologies will work very well in conjunction. A part of the regular manufacturing, either in automotive or outside of the automotive space, would continue to work the way it is working. And the component of additive manufacturing is gradually going to increase as people realize the possibilities of additive manufacturing in their product development requirements. Let me give you an example. BMW started using additive manufacturing for prototyping phase. Along the line, they understood that there are far more applications that are possible with a solution like this. So they started experimenting on the shop floor. And today, they have multiple, when I say in numbers of thousands, hand tools, which they use on the shop floor, which are in some cases up to 60 to 70% lighter than what they were using earlier. Closer home, Honda in Bhiwadi near Delhi, Honda Cars India, they are using our technology for lightweighting their jigs and fixtures. And if time allows, I will show you a few images on how they have been able to convert their heavy metal fixtures, which needed 4 people to lift it and place it on the car windshield and measure the quality parameters by 3D printed, ergonomic, lightweight parts, which are not only much more accurate, but much more lighter, and they save both cost and time for Honda in India.
Right. So please feel free, and if you can just show us those images that you're talking about. I think it's better to have a visual representation, and that should enable our audience to have a much better understanding of technology.
Let me just take a second out of it to share my screen. Let me know when you can see it.
Yes, it's visible
now. Okay. Yeah. So what you see on the screen right now is on the top line, you see the conventional manufactured parts. Okay, these are all metal. And these are, of course, by nature, they are being welded. They are multiple more parts than what you see in the images below. The images below are something that has just notice a few subtle differences. Not subtle, but some of these are quite loud. They are not the same shape as the original part. They are much different. So what the designers and our team applied was designed for additive manufacturing there. They made it ergonomic. They made it, they did part consolidation. So multiple parts were reduced to much lesser number of parts. And the beauty of this was that they actually generated these parts right from the design phase, which essentially means they used the CAD models to come up with this solution, which essentially gave them 60 to 75% reduction in weight. Of course, improved usage on the shop floor, improved employee health and safety, which is also a big concern. If you have metal parts with sharp edges, sharp corners, they can damage employees' health and cause injury. Reduction in cost, of course, adherence to takt time, and of course, much more accurate parts, because they are not waiting for some approximation from a metal forming process. We use the CAD data to derive the model and design it intuitively using softwares, optimize them, and then use it on the shop floor. And these are as good and as sturdy as the conventionally manufactured parts.
Right. And also, this is in terms of the process, Rajiv. So you were also mentioning about some of the interior parts which have switched to using additive manufacturing now. Can we have any of those examples as well? Is it possible for you to give us a visual representation?
So interior parts, Mayank, actually by nature of the industry that we are in, we are involved in a lot of futuristic projects.
Okay.
Customers are not that forthcoming in sharing the products unless they are launched. But in multitude of cases, we are working on EV parts, electric mobility, also taking mobility to the next step, commercial drones, etc., where parts are being churned out using additive. And in many cases, we have completely eliminated the need of traditional manufacturing processes in this format.
Right. And also, I mean, when we talk about some of the niche players, since additive is also sort of a very niche technology. So when we talk about the premium car segment, for example, so are OEMs sort of leveraging this particular technology when it also comes to personalization of these vehicles? And does it make more sense to use additive and offer both personalization as well as lightweighting benefits, and also save on a lot of costs, because this is sort of meant for low volume production, if I may say so?
Correct. At this point in time, yes. And of course, as the technology progresses and multiple more machines and material options are available, it will move to a larger scale of production. But coming back to your point on personalization, actually, one of the key trends that we see in the automotive industry is hyper-personalization. From the times of getting one new model every 4 to 5 years to one facelift to one new model every 6 months to a year is the norm these days.
Yeah.
And we have worked on multiple projects with a lot of customers globally. GM kind of companies, they are looking at automotive grille design, incorporating what they learned from additive to apply it on their model upgrades. We worked on a very interesting project with BMW in China on hyper-personalization. This was a case for BMW Mini, and I could also show possibly a slide on that, so the audience can have a look of what I'm talking about. Just give me a second. I don't have it handy. Forget it. So what we actually did there was, we gave customers a series of designs to choose from and use it as a side lamp, the side scuttle that is used as the indicator option. So not only you could use one of those options, these could serve as something that could use you could change after 6 months, 12 months. It could be a very nice design. It could be somebody's picture. It could be a monument of the city, etc. And these parts were produced in a few thousands of numbers, which essentially means that additive worked closely with the traditional manufacturing processes to make this easily available to the customers. And it's a point of sale solution. So you go to a dealership, you say, okay, I want to personalize my car. I mean, there's no better thing than buying a product which has some of your own design or some of your own intuitions built into it. And they gave also customer an option to give their own design, which they could transform into 3D printing and use it as a side scuttle in the car. So that was one of the examples we did closer home in China. And of course, multiple projects that we are involved in with companies like Maruti, companies like Honda Cars in India, Honda Motorcycles, Hero MotoCorp. Many of these are customers, but all of these, by nature of being futuristic, I don't have much data to share with you right now.
Right. And pressing you on that note only, with increasing digitalization, are we also seeing this sort of, evolving as a trend in the future? Companies giving these options, wide array of options to customers to personalize and, giving their own thoughts and ideas for them to, work upon a particular end result and integrate that particular solution in the vehicle.
Yes, absolutely. So this is becoming a trend because hyper personalization itself is driving the industry, and people are looking at options that they could do. For example, we were at a discussion with the chief designer of a leading automotive company in India, and they actually had a series of bikes designed with some old monuments restored, and the images were built into a part of the design, and it was launched as a collection. So if you look at a collector's edition, or if you look at a series production of a few cars or bikes that are being personalized, it becomes extremely easy tool. You don't have to make huge investments in toolings. You don't have to worry about changes that the customers would ask. You don't have to worry about changing it 6 months down the line, 3 months down the line. This is becoming more and more integral part. What is also becoming more important is people are understanding the possibilities. See, one of the challenges that additive manufacturing industry faces is people think it is either additive or it is subtractive, or they use additive, but they use it the same way as they would use subtractive or the conventional CNC machine. A good use of additive manufacturing actually requires a little bit of unlearning of design for manufacturing and learning of design for additive manufacturing, which essentially means you have zero constraints. You have a part, you have a design, you have any shape. If you can design it in the software, we can print it for you. 3D printer will give it to you the way you want. It could be any ergonomic shape, it could be an undercut, it could be negative draft angle. Today we have Pantone validation. We could give you any color that matches any requirements in your car dashboard. Companies like BMW, Mercedes are actually using a lot of such options for personalization and hyper personalization of their new models, especially in the EV range.
Okay. And from a challenges point of view, Rajiv, so when you talk about so much of possibilities with additive, is material technology sort of an inhibiting aspect right now? I mean, does material availability or the cost of the materials itself, is it sort of innovative in nature?
Correct. So both fronts. It's again a great question. See, what happens is today we have only limited set of materials available to be used for additive manufacturing. So if a customer wants to use a specific grade of polypropylene, it may or may not be available on the additive manufacturing platform that he wants. So to overcome this problem, most companies like ours have tied up with the material suppliers. And at the same time, just working with material supplier is not the solution. I'll give you an example. I was at Evonik in Singapore a few months ago, and they use our machine in the development department of their additive manufacturing solution. So their full-time job is to come up with the new materials, newer options that could enable them to make products well-suited for additive manufacturing at a cost and time which is comparable to the regular manufacturing processes. So this whole drive is towards how well you can achieve material cost, two, how well you can have per part cost that are not only closer to the conventional tooling processes, but they're also finish that you have on the product. Sometimes you require very high finish on the product. By nature, additive sometimes may not give you the same finish. But today, with the advancements in technologies, it is difficult to differentiate between an injection molded part and a part from, let's say, technology like Origin P3 that Stratasys has, which is just just produced using a 3D printing process.
Right. And through the day, we have also discussed about, different parameters of a vehicle, in terms of the dynamic performance and as well as in terms of the noise and durability performance. So when it comes to using additive manufactured components, so are they able to perform to the same level, or do you think that there's more scope for improvement there, or is it already at a very advanced stage compared to traditional manufacturing processes?
Well, I think this is where the whole ecosystem will come in play. It's not something that you would do in isolation, right? Okay. So you will have to have involvement of various parameters, have the data inputs right from design phase into the manufacturing and evaluate those. So I think it would be, I think, comparable to what you would do using traditional manufacturing processes. At the same time, giving you freedom to modify them faster and better with lesser constraints in the process that you have.
Okay. And I'll come to taking questions from the audience, Rajiv. And, there's one question that if you can elaborate more upon the 3D printing materials that are available to OEMs at this point in time.
Okay, so there are multiple classifications of material that we use, starting from general basic materials like ABS M30, ESD, which is electrostatic discharge, PLA, which is the simplest form of plastic material that we use, to materials that can take you to higher end of engineering requirements, which is polycarbonate, PCABS, nylon 12. And then there is something called high performance materials, which are, for example, flame smoke toxicity conversant. And also there are materials which are used for lightweighting as an example. So one of the most important used material is nylon 12 CF for lightweighting. Companies like Ducati actually are producing wheels using nylon 12 CF, and they are no longer using metal in the process. So today we have a wide variety of materials already available with a definite view of working collaboratively with material partners to extend this even further.
Okay. I'll take the next question from Mr. Paul, and the question is, will you use lattice structure modeling in the future? I mean, this I think is directed towards OEMs, but he wants to understand about the lattice structure modeling with respect to future lightweight structures.
So definitely we can. Anything that you would generate a model out of in the CAD software and analysis software to that matter would be easily printable in a 3D printer. So for us, it's all the backend that works in collaboration, and the end production using additive manufacturing has no process limitation. So yes, very well we will use that.
Right. And I'll come back to the cost angle, Rajiv. So, would you be able to give us some sort of a ballpark number in terms of, what sort of volumes can an OEM target in terms of, achieving the price parity between traditional processes and additive manufacturing?
This is actually a little tough question to answer straight off, because additive manufacturing as a technology depends a lot on the geometry of the part, the shape of the part, the material that you would use, and there's no direct comparison available. But to give you a perspective of what percentage of parts in the near future you would see additively manufactured, if I give you some high level numbers, today auto component market in 2018, for example, was about 165 billion US dollars globally. It is projected to grow to $460 billion by 2025. If you look at additive manufacturing, today we are at about $2 billion in automotive components, mostly into prototyping phase. About 2025, this number will become close to $10-11 billion as per projections given by US car authorities. And now 33% of that $11 billion would be end-use part production. So from today, which I would say is not less than 5 to 7% of end-use parts in the automotive industry, it's expected to grow to almost 33% in the next 5 odd years.
Right. So there's a huge growth potential for additive.
Huge growth potential.
And my last question, so is electrification also going to be one of the enablers in this whole push or the drive towards use of additive manufacturing?
Absolutely. Absolutely. I think EVs is a part of life, and we are rapidly beginning to see them on the roads. EVs, by virtue of the design, they have heavy power electronic systems, they have power management, distribution, charging requirements, traction inverters, and so on. These are areas where additive can play a definitely big role, both in optimizing the cost and assembly configuration, as well as with a huge potential of lightweighting. Another important thing that additive manufacturing provides as a complete ecosystem is how well you can integrate the sensors, the antennas, the cablings, etc., as a part of the vehicle structure itself. So which essentially means you don't have to create new parts, new assemblies, new part numbers, etc., for that, new suppliers for that. So producing, let's say, 10, 12 different components as an integral design with similar or better strength in the electric vehicle opens up huge possibilities for the industry. I mean, I think it is the imagination also. Sometimes I feel, if somebody asks me what is the biggest challenge in India in terms of 3D printing adoption, I would say 75% of it is ignorance. Ignorance about the possibilities of where it can be applied. Huge possibilities. You have 10 different parts, sub-assemblies, some IoT devices, some antennas. All of that can be integrated along with software systems and then very creatively manufactured as a single piece. And we have similar pieces not just working in EVs but also going into space as an example. leading organizations in globally and in India are using it for manufacturing products that are just manufactured additively and sent into space. Forget about lightweighting requirements of the EV industry. The challenges there are even bigger. The aircraft industry is even bigger. So I see huge possibilities for the EV industry. Just because it is going to be at a consumer scale, the numbers are going to be huge.
Right, and that should drive the cost down as well. When you have the economies of scale coming in, so that should also be a fillip to the reducing the overall cost of the technology itself.
That's true. That's very right, and that's one of the key ingredients of the overall adoption now for both 3D printing as a manufacturing technology and the usage of materials in the process.
Right. On that note, we'll just close this conversation here. And Rajiv, it was lovely talking to you and getting all the insights.
Pleasure.
We have completely run out of time on this first day of the event. Really appreciate you joining us and getting your thoughts to us across, on additive manufacturing and generative design. Rajiv Bajaj, the MD of Stratasys India and Southeast Asia. So with that, we'll close the first day of the Autocar Professional Vehicle Lightweighting Conference, which is brought to you by BASF and Henkel, which are our partners for this virtual event. And if I may just summarize quickly, we had 3 interesting sessions today, starting with the keynote address by Mr. Venkatram Mamilapalli, the MD of Renault India. And, he talking about how lightweighting is very key from a sustainability point of view, how companies are now driving the whole lightweighting methodology simply because, there is mandate to become carbon neutral and decarbonize. So that is, sustainability has emerged in our conversation today as one of the key drivers for lightweighting for the automotive industry. And then going forward, not just lightweighting solutions, in our normal understanding could be understood to be high in cost, but that's not the case, as Mr. Venkatram had mentioned in his presentation. So when you talk about the optimization of the vehicle weight in the correct form, and when you mix that with the economies of scale, I think cost also evens out in the longer run, which was also seconded by our panelist, Dr. Tapan Sahu from Maruti Suzuki India, who also mentioned that, if you are investing initially into a platform which can allow you to make multiple models out of the single platform, so cost eventually evens out. And from the supplier side, we had Mr. Sitaram Kritikumar, who is the vice director from BASF India, and he also mentioned about the need for localization of some of these specialized materials and how the industry is also improving the entire supply chain to offer some of these specialized materials locally within India. And we had the presentation from Mr. Naresh, and finally, we've just concluded the session, interview session with Mr. Rajiv Bajaj. So with that, I think we had an all-encompassing discussion on the auto industry's progress in lightweighting today, and would request you to also log in tomorrow. We have an engaging lineup of discussions available tomorrow as well, starting with the keynote address from Dr. Royston Jones, who's the CTO of Altair. And he'll be giving his presentation about the optimization of vehicle weight by the use of new generation materials which are available to the automotive industry. So we look forward for you to joining tomorrow as well. And until then, it's a goodbye from me for now. Thank you so much for joining in today.